A very good morning to all of you. We were talking about P block elements where we have completed reasoning questions from group 15, that is nitrogen family. Then we have completed reasoning questions from group number 16, that is oxygen family. And now the next group is your group number 17 or 7th A, which is also called halogen family. Halo stands for salt and gen stands for producer or generator. These elements, being non-metallic, combines with metals to form salt. That's why these are called halogens. As the group number is 17, so number of valence electron will be 17 minus 10, that is 7. Or if we use the Roman numbers for the group 7A, 7 represents the number of valence electrons. So their general electronic configuration can be written as Ns2np5. In S subshell we are having 2 electrons and in P subshell we are having 5 electrons. If you remember, P subshell can accommodate maximum of 6 electrons. So P subshell is deficient of 1 electron only. If this atom can get 1 electron, then this atom will complete their octet or they will acquire the electronic configuration of nearest noble gas. Then the elements fluorine, chlorine, bromine and iodine. Fluorine is the first element of this group, followed by chlorine, then bromine and then iodine. Fluorine belongs to second period. So fluorine does not have vacant d orbital because for second energy level we don't have d subshell. That's why fluorine exhibits some anomalous properties. Fluorine cannot expand its octet because vacant d orbitals are not there. There are a few other properties also. That is not important here. While for the others, d subshell is possible, so they can expand their octet. They can form more than one bond. Then, point number 1. Completely non-metallic group. It is the only group of the periodic table which contains all the elements as non-metals. All elements of this group are non-metals. There is no other group where all the elements are non-metals. Iodine is a non-metal which is having metallic luster. Iodine shines like a metal. Then, the high electronegativity. Whenever we talk about any period, then group 17 is at the last. We are not bothered about group 18 because these are non-reactive in nature. So group 17 elements are last or just before group 18 in any period. So their atomic size is very, very small. and due to this they have high values for electronegativity. Reason is small size. Fluorine is the most electronegative element of the periodic table. Now as we move down in a group, as we are moving from fluorine, chlorine, bromine to iodine, then value of electronegativity decreases due to increase in size. As we move down in a group, atomic size increases. Electronegativity is inversely proportional to atomic size. If atomic size increases, electronegativity decreases. Then comes next one. Due to high electronegativity, they are highly reactive. Remember, if the elements are highly electropositive, they will be reactive. If the elements are highly electronegative, then they will be reactive. So due to high electronegativity, they have more affinity for highly electropositive elements or metals. That's why these elements does not exist in free state in nature. They undergo chemical combination with metals and form the compounds. Then next one, ionization energy is very high. Means high amount of energy is required to remove the electron from the outermost shell from an isolated gaseous atom. Or in simple, high amount of energy is required to remove the electron. What's the reason? Small size. Due to small size, valence shell is closer to nucleus. So valence electron feels more force of attraction from the nucleus. Against this force, if we want to remove the electron, we are going against the force. And for going against the force, we require high amount of energy. That's why their value of IP is more. As we move down in a group, value of IP decreases. Reason? The atomic size. As we move down in a group, atomic size increases, as a result of which value of IP decreases. Iodine can form I plus ion. Iodine can lose electron because size of iodine is maximum in group number 17. Then comes physical state. You know it very well that halogen atoms are having 7 electrons in the valence shell. All halogen atoms require one more electron for completion of the octet. So halogen combines with another halogen atom by sharing of one electron, as a result of which they exist in diatomic form. They are diatomic molecule. In a molecule, there will be 2 atoms. And what is important about halogens? F2 and Cl2 are gases, while Br2 is a liquid and iodine is a solid. The first 2 members, F2 and Cl2, are gases. Br2 is a liquid while iodine is a solid. Reason is very simple. Whenever we talk about van der Waals force of attraction, this force of attraction increases with increase in size. It is the only force which increases with increase in size. Iodine is having the maximum size. So between the iodine molecules, van der Waals force of attraction is maximum. That's why the physical state for I2 is solid. Remember, I2 is a volatile solid, or we can say it shows sublimation. On heating, iodine gets directly converted to gas state. There is no liquid state in between. So iodine is a sublimable solid. The solid state directly converted to gas state on heating, Then comes about electron affinity. How much force of attraction they are having for the incoming electron. Is written, they have high values of electron affinity. Reason is very simple. They have a small size. They have 7 electrons in their valence shell. They simply require one more electron for the completion of the octet. That's why they have high affinity for the incoming electron. An electron can be added easily, and in this manner they can complete their octet. So force of attraction is there between incoming electron and the nucleus. So energy is released. So in other words, in other terms, electron affinity can be called as negative electron gain enthalpy. Electron gain enthalpy means energy released when electron is added. Why it is negative? Because energy is released. The process is exothermic in nature. Addition of electron in halogen is exothermic in nature. That's why term negative is used before electron gain enthalpy. More negative the value for electron gain enthalpy, more will be the affinity for the incoming electron, more easily the electron will be added. Now here comes one important exception, and it is between fluorine and chlorine. We know it very well that fluorine is having highest electronegativity. The electronegativity of fluorine is more than chlorine. But still, electron affinity of fluorine is less than electron affinity of chlorine. Or the value for negative electron gain enthalpy is less for fluorine if it is compared with chlorine. Reason is very simple. In fluorine, incoming electron is added to 2p subshell. And in chlorine, incoming electron is added to 3p subshell. Size of 2p subshell is less, and already 5 electrons are there. In total 7, 2 in 2s and 5 in 2p. So due to presence of 7 electron in second energy level, the incoming electron feels some force of repulsion from the electrons already present. There exists inter-electronic repulsion. But inter-electronic repulsion is absent in chlorine due to more size of 3p, or we can say third energy level. Chlorine is also having 7 electrons in third energy level, but size is more, so incoming electron can be added easily. This is the reason electron affinity of chlorine is more than electron affinity of fluorine, although electronegativity of fluorine is more than chlorine. Important exception in inorganic chemistry. Then comes the oxidation state. Fluorine, the most electronegative element of the periodic table, never shows positive oxidation state when it forms compound with any other element. Reason is very simple. It is the most electronegative element. It can take electron from any other element, but it cannot lose electron to other element. That's why in most of the compound, in all compounds, it exhibits -1 oxidation state, but for others -1 or +1 is possible. Reason, if Cl is coming with oxygen, electronegativity of oxygen is more than chlorine. So what O will do? O will attract 1 electron from chlorine. O will attract 1 electron from chlorine, as a result of which Cl will get +1 oxidation state. So +1 -1 depends to which type of atom they are combining. If more electronegative element is there, then halogens except fluorine will show positive oxidation state, and if these are combining with element having less electronegativity, then they will show negative oxidation state. Also they can show +3, +5 and +7 also, because unpairing is possible in chlorine, bromine and iodine due to presence of vacant d orbital. Vacant d orbital is not there in fluorine, that's why fluorine will always exhibit -1 oxidation state. No other OS is possible for fluorine. Then comes next point, halogens are colored. All halogens are colored. Reason is very simple. The electrons present in the valence shell gains energy from the visible region and get excited to higher energy level or higher energy state. In higher energy states, the electrons are not stable. So what they will do? They will emit light and comes back to the ground state. The emitted light falls in visible region. It belongs to visible region. And that's why all halogens are colored in nature. Then comes your hydrides. Halogens are combining with hydrogen. H is having only one electron. So the possible hydrides are HX type. It will be HF, it will be HCl, it will be HBr, it will be HI, and all hydrides are covalent in nature. Because hydrogen is also a non-metal. H is sharing its electron with fluorine, chlorine, bromine or iodine and is forming single covalent bond. But the important point here is that except HF, all other hydrides are gaseous in nature. HF is liquid. Reason is simple. In HF, H bonding is present. In HF compound, molecules are associated via H bonding. H bonding is absent in HCl, HBr, HI. So HCl, HBr, HI are gaseous in nature, while HF is liquid in nature. You know the meaning of H bonding? When hydrogen atom comes in between highly electronegative elements like fluorine, oxygen and nitrogen, then there exists a force of attraction between the different molecules, and this force of attraction is called H bonding, which is possible in HF only. Or we can say the boiling point of HF is more than HCl. Reason? H bonding. Then comes acidic strength of hydrides. If we talk about the acidic strength, then HI is the strongest acid among the hydrides of halogens. HF is weakest. The increasing order of acidic character follows the order HF less than HCl less than HBr less than HI. Reason? Why? What can be the reason? When a compound exhibits acidic property, when it can release H plus ion? If release of H plus ion is easy, then acidic character of compound will be more. The size of F is smallest among the halogens. So bond length is very small in HF. Bond strength is more in HF. So release of hydrogen in the form of H plus is not possible. Also, there is a H bonding. But if we talk about HI, atomic size of iodine is largest among the halogens. So bond length of HI is maximum. Bond strength is minimum. So release of H in the form of H plus ion is easy. So based on bond strength, we can explain the acidic character of hydrides of group 17 elements. HI is strongest acid here. Then comes your interhalogen compounds. What are interhalogen compounds? When a halogen combines with another halogen, the compound formed are called interhalogen compounds, like FCl, BRF3, etc. etc. When a halogen atom combines with another halogen atom, then the compound formed are called interhalogen compounds. Remember, these compounds are more reactive than the halogen itself. If we talk about FCl, then it is formed by combination of Cl and F. This FCl is more reactive than Cl2 and F2. due to weaker bond. Due to weaker bond. Now, the types, if one electron is shared between the halogen, we will get AX type of interhalogen compound. Example, ClF-BrF, one electron is shared. Then we have AX3 type. A is your central atom, X is your surrounding atom. Remember one thing, central atom must have less electronegativity than surrounding atom. If surrounding atom is having more electronegativity, then it can cause unpairing of electron. In central atom, electron can be excited to vacant d orbital, creating more unpaired. So here AX3 type, ClF3BrF3. Just see, Cl is central, F is surrounding. Electronegativity of central atom is less than surrounding atom. Then we have AX5 type. We require 5 unpaired electron. Examples, BrF5, IF5. Then we have last type, AX7 type. Only one example, that is IF7. We require 7 unpaired electron. For creating 7 unpaired electron, there should be maximum electronegativity difference between the combining halogen atoms. And it is possible between fluorine and iodine. Iodine is having maximum size. Fluorine is having minimum size. Electronegativity of fluorine is much more than iodine. In iodine, vacant d are present. So fluorine can create 7 unpaired electrons by excitation of the electrons from P and S. Electrons will be jumped to, excited to D from P and S. As a result of which we will obtain 7 unpaired electrons. And it is possible with I and F, so we get IF7. So this is all about the reasoning questions from group 17 elements. From tomorrow onwards, we will start chemical reactions, important chemical reactions of group 15, group 16, group 17 and group 18, that is your noble gas. Thank you and have a nice day.